Good morning, Prof. Ong. Hope you are in the pink of health. So today, I'm very happy and delighted that I will be presenting on my subject operating system, which entitled body system and binary tree. So in this presentation, I will be explaining on the simple terms of binary body system and the figure to elaborate on body system and binary tree. So before I start my presentation, let me introduce myself first. My name is Jiaqin and I'm currently pursuing bachelor degree in electronics engineering technology with the major of electronic network design. Without further ado, let me start my presentation. Okay, so what is body system actually? So body system can be defined as an algorithm in which a larger memory block is divided into smaller and smaller partitions that need to satisfy the request. Okay, so it is considered as another memory allocation system beside that first fit, next fit, best fit, and worst fit, which this memory allocation we have been studied previously. So I will be just focusing on body system today, and the body system memory allocation is based on the idea that allocated blocks are all in the power of 2. Let's say if the size of the request is smaller than the smallest allocation unit, and it will set the n to be the smaller side. Okay, so to let you understand, I will briefly give an example. So for example, if the allocation blocks is something like 60k, okay, 60k, right? So we may use 2 power of 6. So 2 power of 6, you will get 64k, right? So if 64k, so it's enough to cater the 60k, the allocated block. Okay, understand? So if I'm using 2 power of 5, it's not enough because 2 power of 5 you will just get 32, right? So 32k memory size is not enough to cater the 60k just now. So yeah, that's just a simple explanation on what body system is. Okay, to let Prof Ong to understand more about what body system is, and I would like to elaborate with this figure. So I have allocated my memory into 1024k, which you can see from here, 0, 128, 256, and so on until 1024k. So this is the default 512 for easier expansion later on. Okay, so next, so first request, that's the 70k allocated block that want to enter this memory. So this body system need to figure out, I need to find 2 power of something. So 2 power of 7. So 2 power of 7 enough to cater for 70k block because there's 128 is 2 power of 7, right? So if 2 power of 6, 64 is not enough to cater for 70k. So you need to find a larger one. Okay, so next. So for B, 35k. So same go to process B, need to find for 35k. So 35k, you can see 35, 128, 64. So 64. So need to find 64 to cater for this 35k. So you can see from the second bar, the 128, I have divided into portions 64 and 64. So 64 is easier for my uh, allocation 35k block later on. Okay, so that's all for process B. Okay, next, there's process C. So process C that say I would like to use 80k to allocate this memory. So 80k, so you can see 80k just enough to cater for 2 power of 7, right? 128. So you need to find another 128 to cater. So you can see from the third partition, I have entered this C equal to 128, 80. So which means what? Means that 80, the allocation block just now, has been allocated in this 128 2 byte memory block. Yeah, okay. So next, so a negative 70k. So what is the negative sign means here? So the negative sign means here the release of 70k. So just now I have allocated allocated 70k just now, right? So I need to release the 70k now. So I will be just probably find the 70k, and yeah, that's the 70k, which is the first box, right? So it will just release this 70k, and this 128k 128k memory can be just used later on by another process. Okay, so same goes to D. So D is coming in. So what I'm just now mentioning about is 128 will be finding another process, right? So for this case, the 60k. So 60k is no need use until 128 because 64k is enough to cater for 60k. Okay, so we may just probably use the box beside the B. Okay, so you can see the 60k is occupy this space. Okay, next. So next, negative 35k. So like what I have explaining just now, 35 negative, it seems that the release of the memory block. So now I will be saying B say I want to release this 35k from this memory. So it will be searching for 35k, and yeah, I'm searching the second box, right? So it will just release this 35k, and this 64k is now available, and yeah, is not captured by anyone, any block. Okay, so next, okay, 60k. So same go to just now what I have explaining. So 60k, it will just find a 60k, and yeah, so in this block 60k is third box, right? So it will just finding this third box and just release it. That's all. Okay, so once it release, it will just add up the total 256, which is the available unit for the allocations to be allocated. So it's available. So if any process is coming in, they may just use this 256k. Okay, next. So negative 80k. So there's now just left the C block, right? So the process C is now allocated the 128k block. So once this 80k is released, and this body system will be free. So it's now available for 1024k. So it may be used by other process later on or anything. So it's not occupied by any uh, mem memory block again. So that's all. So now I would like to further elaborate on the binary tree. So the binary tree is something like the expansion of this now body system. So I will be just taking the fifth bar, the 60k, D plus 60k, this bar for me to draw the binary tree. Okay, so from here you can see the left side, I have mentioned the root, available, and occupied. So in white color, gray color, and green color circle, and beside left side, a right side, you can see there's the allocation of 1024k, 512k, 256, 128, and 64. These all are the all allocation based on 2 power of n. Okay, so next. Okay, so from here you can see the white color, the root. So you can see the root is the white color. One is the mother, which is 1024. It's divided into two portions, 512 and 512. So the right side 512 is available, which you can see the arrow is pointed, right? Pointed down straight forward is, yeah, the gray color is available, which means that this 512k is available. Okay, next, okay, I will be just continue expand to into 256 and 256, 2256, and the 256 will be continue to expand to 122. The four. You can see 1, 2, 3, 4, right? So there's 128k. So okay, you can see the gray color, the first gray color, 128k is pointed straight forward to the first box. So which means that this 128k is available. Okay, so next, you can see there's a special that 128k I still further expand into 64k and 64k. This 64k was occupied by the B and D just now. So the B is the previously the body system that the 35K, and the D is now the process D is now want to allocate the 60K. So 64K is enough to cater for this both process. So in no need use until 128K, which will be a wastage for memory. Okay, so next the green color. So the next the process C, the fourth box, you can see there's the 80K. The process C just now is occupied by this memory. So the 80K cannot use 64 because it's more than the space. So we need to use until 128K, which 2 power of 7. So next, the last second box is 128K, which is available, and the last also what I have mentioned just now, 512K is available. That's all for binary tree. And I hope that Prof is understanding what I'm talking about, and I'm very happy and delighted that I have the chance to present and enhance my presentation skills through the speakings and others. So I hope Prof is happy to listen when listening to my presentations, and that's all from me, and thank you.